Okay, this is page 9 of the Polynomials booklet. Now we're looking at multiple zeros of a polynomial. Now, a polynomial of degree n, we know, has n zeros or roots, but those roots are not always different. If the factor z minus c occurs more than one time, let's say r times, then we say that c is a zero of multiplicity r. A multiple root is where the same root appears more than once in a polynomial. For example, if we look at this polynomial in z equals z minus 4 cubed times z minus 1 squared times z plus 2. Now, z plus 2 really is z minus negative 2. Then the 4 is a root of multiplicity 3 because it's z minus 4 cubed. And the 1 is a root of multiplicity 2. And the negative 2, because this is z minus negative 2, is a root of multiplicity 1. Now, just using this particular polynomial in x equals 2x cubed minus 11x squared plus 20x minus 12, we just want to show that x minus 2 is a double root. Okay, so what I'll do, we'll just show that we'll use the factor theorem. And do p of 2 is 2 times 2 cubed minus 11 times 2 squared plus 20 times 2. Remember, if x minus 2 is a factor, then p of 2 should equal 0. Okay, minus 12. And if we work that out, we get 2 times 2 cubed, that's 16. So we've got that 16 minus 11 times 4 is 44. And we've got plus 40 minus 12. And that's 56 minus 56, which is 0. So therefore, we can see that x minus 2 is a factor, or 2 is a root, okay? So if we know that x minus 2 is a factor, what I'm going to do now is long division, x minus 2 into 2x cubed minus 11x squared plus 20x minus 12. And first x goes into 2x cubed. We've got 2x squared times 2x is 2x cubed, and 2x squared times negative 2 is minus 4x squared. Subtracting, we get 0 there. Negative 11 take away negative 4. We get negative 11 plus 4 is negative 7x squared. Now up here we'll go minus 7x, so minus 7x times x is minus 7x squared. Let's just bring down this 20x. Okay, we've got minus 7x squared. Minus 7 times negative 2 is plus 14x. Subtracting, we get 0. 20x minus 14x is 6x. Bring the minus 12 down. And x into 6x is plus 6. So we've got multiplying 6 by x, we get 6x, and 6 times negative 2 is take away 12. Sorry about that. And therefore we get 0. So therefore, we can say that our polynomial in x is x minus 2 times 2x squared minus 7x plus 6. And let's try and factorize this second bracket here. And we'll have 2x and x. And let's just look for some factors of 6. If we put 3 and 2, I don't think that'll work, but if we put 2 and 3, and a negative times a negative is a positive, let's try that. We've got 2x squared minus 4x minus 3x plus 6, and that works. And so therefore, we can say that our polynomial in x, here we've got x minus 2 twice, so it's x minus 2 squared times 2x minus 3. So therefore, x minus 2 is a double root of our polynomial. Now, this is not how we would normally do it, okay? There's going to be an easier method. Now, what I'm going to just do, I'm going to write down what my polynomial in x is. It's 2x cubed minus 11x squared plus 20x minus 12. Now, what I'm going to do is look at the first derivative of this polynomial. So p dash x is 3 times 2, it's 6x squared minus 22x plus 20. Now, if we factorize that, we get 2 bracket 3x squared minus 11x plus 10. And if we try and factorize that, looking for factors of 10, we've got 10 and 1 or 5 and 2. I think if we go 5 and 2, 2 negatives make a positive. We've got 3x squared minus 6x minus 5x, which gives us minus 11x plus 10. So this is being factorized. So what we notice is that x minus 2 is also a factor of p dash x. So x minus 2 is a double root of px. However, in this case, x minus 2 is a single root of p dash x, okay? So if we just look at p dash 2, this of course should equal 0, just putting it in here, or if you put x is 2 here, this will become 0, so the whole thing becomes 0. I can just put it there, and I get 6 times 2 squared minus 22 times 2 plus 20, and that's 24 minus 44 plus 20, which is 0. So therefore, x minus 2 is a single root of p dash x. So here are our critical bits of information. That x minus 2 is a double root of px, of p of x. But if you do have a double root, then, so x minus 2 is a double root of p of x, and we'll find that x minus 2 is also a single root of the first derivative, p dash x. So that brings us to our theorem. And the theorem is, if a polynomial p of x has a root of multiplicity r at x equals c, then its derivative, p dash x, will have a root of multiplicity r minus 1. So the multiplicity of the root will be 1 less than what it was for the original polynomial at that same position of x equals c. And taking this one step further, the second derivative, p double dash x, will have a root of multiplicity r minus 2 at x equals c. Okay, so that's the multiple roots theorem. Okay, now the proof of this. If we let p of x equal x minus c to the power of r, so therefore we've got a root, or the factor z minus c or x minus c occurs r times, or we can say that c is a root or a 0 of multiplicity r, then if we apply the product rule here, so if I want to differentiate p of x, I'll have to apply the product rule because here I've got a function in x minus c to the r, and qx is a function in x. So I'll let u equal x minus c to the power of r. And so therefore u dash is r bracket x minus c to the r minus 1 times, if you differentiate what's inside, you'll get 1. Okay? And here, if q is q of x, so we apply the product rule because we've got a function times another function, and v dash equals q dash x because we do not know what the function is. So applying the product rule, here we've got v times u dash plus, here we've got u times v dash, okay? So the first derivative, p dash x, as we can see, is v times u dash plus u times v dash. Now, let's see if we've got a common factor here. What we're going to pull out is x minus c to the r minus 1 is smaller than x minus c to the power of r. So the smaller factor here is x minus c to the r minus 1. If that's pulled out, we've still got r times q of x plus r minus 1 plus 1 gives us r. So there's still one lot of x minus c, you see, because that's to the power of 1, times q dash x. Now, we'll just put all of this together, this bit here in the bracket, and so therefore this is x minus c to the r minus 1 times sx, where we've just let sx be this new polynomial here, okay? So therefore we can see that we have a root, x equals c is a root of multiplicity r minus 1. Whereas in the original function, x equals c was a root of multiplicity r. Okay, now let's just apply the product rule again to p dash x to find the second derivative p double dash x. Now if we look at these, we've got again that u is x minus c to the r minus 1, and u dash is r minus 1 times x minus c to the r minus 2 times the derivative of x, which is 1. And again, v is s of x here, and v dash is s dash x. And applying the product rule, we can see we've got v u dash plus u times v dash. Now the common factor here is x minus c to the power of r minus 2, because the r minus 2 power is smaller than the r minus 1 power by 1. So we pull out x minus c to the r minus 2, and what's left over, if that's pulled out as a common factor, you've got r minus 1 times s of x plus 1 lot of the x minus c to the power of 1 times s dash x. Now if we just let this new bit be a new polynomial called rx. So therefore this is a polynomial with x equals c as the root of multiplicity r minus 2. So the second derivative, the root of multiplicity, is 2 less than the original one. For the first derivative, the root of multiplicity is 1 less than the original polynomial function. Okay, so that's the proof of that. Now we're on page 10 of the Polynomials booklet, and the question is to solve x cubed minus 4x squared minus 3x plus 18, given that it has a root of multiplicity 2. So if it has a root of multiplicity 2, we need to look at the original function, which is x cubed minus 4x squared minus 3x plus 18. We need to look at the first derivative, which is 3x squared minus 8x minus 3. And we need to look at the, actually we'll just look at the first derivative still, and we will factorize it. Okay, we should get 3x, I think we'll have minus 3 plus 1. So we've got 3x squared minus 9x plus x minus 3. Now if we want to solve p dash x equals 0, see the thing is, instead of trying to find one of the roots in the original function by looking for factors of 18, because you know that it's got a root of multiplicity 2, what you can do is find the first derivative, factorize it, put that equal to 0, and then you'll see which one of these factors that you're going to get. So let's just see what we've got. Let's solve this. Therefore 3x plus 1 equals 0, or x minus 3 is 0. So we get x is negative a third, or x is 3. So either one of these is going to be the double root. Okay, so as your polynomial in x, which is equal to 0, has a double root, then the solution to p of x equals 0 must be either x equals 3 or x equals negative 1/3, but not both. Now the reason is, if they were both multiple roots of multiplicity 2, you'd have x minus 3 squared and 3x plus 1 squared, and you'll end up with something to the power of 4. But this polynomial is only to the power of 3. So therefore we've either got a double root at x is 3 or a double root at x is negative a third. Now we know that p of both of these, p of 3 is 0, so p dash 3 is 0, and we know that p dash negative a third is 0. If one of these is the multiple root, then the original function, so if we substitute 3 and negative a third into the original function, one of those has to equal 0. So notice I'm putting it into the original function now. So p of 3 is 3 cubed minus 4 times 3 squared minus 3 times 3 plus 18, and that's equal to 27 minus 4 9s are 36 minus 9 plus 18, and that is negative 45, and that's plus 45, so that appears to be 0. So therefore it appears that x minus x equals 3 is the double zero. Okay, sorry, that's off screen. So therefore x minus 3 is the double zero. So that means, let's just double check if you would have tried p of a third. So just checking, if we do p of a third into the original equation, which is here, we get negative 1/3 cubed minus 4 times negative 1/3 squared minus 3 times negative 1/3 plus 18. Okay, we get negative 1 on 27 minus 4/9 plus 3 plus 18. Now there is no way that 21 minus these two small fractions is 0. Don't even work out what it is. It's just not equal to 0. So look, we did p of 3 in the first place and we got that it was a double zero anyway. But I was just showing if you did p of negative 1/3 first and you didn't get 0, you would have then tried p of 3. So therefore your polynomial in x is x minus 3 squared, so I'll just write it as x minus 3 times x minus 3. Now, it is a monic polynomial, so we've got x minus 3, because they're two of the factors, and I'll just put x minus alpha for the last factor. Now, we know that the constant term of this polynomial is 18, so we can say that negative 3 times negative alpha is positive 18. So we get 9 times negative alpha is 18. So therefore alpha is negative 2. So therefore your polynomial in x is, we know that that's x minus 3 squared times x, take away negative 2, or x plus 2. Okay, so that's the factorized form of your polynomial. So it does say to solve that. So in other words, we have to find the x values or the roots. So therefore the roots are 3, 3 and negative 2. Notice that we've got the double roots at 3 and another single root at negative 2. Okay, now when you've got a root of multiplicity 2, you just look at the, you look at the original function and only the first derivative. Okay, when you've got a root of multiplicity 3, you look at the original function, the first derivative and the second derivative. Okay, see, because if the original function has a root of multiplicity 3, p dash x will have a root of multiplicity 2, and p double dash x will have a root of multiplicity 1. So if your function has root, so I'll just write that over here. If p of x has a root of multiplicity 3, then p dash x has a root of multiplicity 2. So if p of x has a root of multiplicity 3, then p dash x will have, or has, a root of multiplicity 2, and p double dash x has a root of multiplicity 1. This is, of course, at the same x value. So let's look at the original function. And it's 4x to the 4 minus 21x cubed plus 30x squared plus 4x minus 24. So let's write out the original function. Then we will differentiate it twice, finding the first derivative and the second. So the first derivative, 4 times 4 is 16, x cubed, minus 21 times 3 is 63, x squared, plus 30 times 2 is 60x plus 4. That's your first derivative. The second derivative will be 48x squared minus 126x plus 60. Now, of course, this second derivative is going to be the one that's going to be easier to factorize. So let's see what numbers go into 48, 126 and 6, or what factor. Looks like 6 is a common factor of all of those. So 6, pulling 6 out, 6 times 8x squared minus, that would be 21x plus 10. Now that can't, we can't pull out any constant term again. So let's see if we can factorize. So we're either going to have 4x and 2x, and we can just play around a little bit, 4x and 2x, or it's going to be 8x and x. So let's have a look with 4x and 2x. Factors of 10 could either be 10 and 1. That is not going to give me 21. Either way, if the 10 was there, the 1 was there, that doesn't work. Could be 5 and 2. That gives me 20. And 4, that's not going to give me 21. I can go 5 and 2, that's going to give me 10, 16, or 4. That's not good. We'll try 8x and x. Factors of 10, let's try 2 and 5. That'll give me 16, that'll give me 5. They can combine to give 21, so we'll go minus. So we've got minus 16x minus 5x and plus 10 there if you multiply those two. So our factorization will be 8x minus 5 and x times x minus 2. Now, we have to decide which of these is going to be the root of multiplicity. Okay, now, if you just look at this, we know that 5 is not a factor of 24. Like if you look up here, I suppose we could have said the same thing, that actually, well, negative a third could go into 18, and so could 3. 3 is a factor of 18. So either of, actually, sorry, I should just look here. 1 is a factor of 18 and negative 3 could be a factor of 18. So therefore, either of those could have been the root of multiplicity too. But if we look here, we know that 5 is not a factor of 24. So note that 5 is not a factor of 24. So therefore, the multiple root is x equals 2. But let's just check that. We're going to check p of 2. So let's see, p of 2, putting it into the original function, is 4 times 2 to the power of 4 minus 21 times 8, that's 2 cubed, plus 30 times 4 is 120, plus 4 times 2 is 8, minus 24. And just working that out, you can just get your calculator and you will get that that is 0. So therefore, we can see that we've got a multiple root here, because x equals 2 was the solution for the second derivative. It's also a solution for the original function, and we should find that p-2 will give us 0 as well. So p-2, that's 16 times 8 minus 63 times 4 plus 60 times 2 is 120 plus 4, and if this is calculated as well, we get I think this is 128 minus 232 plus 124 there, and that gives us 0 as well. We know that p-2 is going to equal 0 as well, because it was a solution here when we put it equal to 0. Okay, but just doing it anyway, I get 48 times 4 minus 126 times 2 plus 60. Calculating that out on a calculator, I get 0 as well. So therefore, we can see that p-2 is 0, p of 2 is 0, p-2 is 0, and p-2 is 0. So therefore, we've got a root of multiplicity 3. So we've got, therefore, your polynomial is x minus 2 cubed times, now because it's not a monic polynomial, I'm just going to write times, I'm just going to put it as ax plus b, okay, because it could be 2x. Well, it's probably going to be 4x plus something. Now, so therefore it's x minus 2 cubed times 4x plus some term. Now, if we look at our original polynomial, the constant term is negative 24. So therefore we can say that negative 2 times negative 2 times negative 2, or just negative 2 cubed, times b is negative 24. So we get that negative 8b is negative 24. So therefore b is 3. And so therefore your polynomial in x is x minus 2 cubed 4x plus 3. Okay? So we've just been asked to factorize that. And if you were asked to solve it, you would get your solutions are x is 2, 2, 2, and negative 3/4 as your solutions to that polynomial if it was actually put equal to 0, but it's not. Page 11. Now if your polynomial in x, which is equal to x cubed minus 3x squared minus 9x plus c, has a double zero, the question is to find c and factorize polynomial in x over the real numbers. So if it has a double zero, then I'll just rewrite it. P of x is x cubed minus 3x squared minus 9x plus c. So that will have a root of multiplicity 2, the original function, and p dash x will have a root of multiplicity 1, and p dash x is 3x squared minus 6x minus 9. Now, if I put that now equal to 0 and solve, I can obviously divide through by 3. So I get, or factorize out the 3. So I get 3 bracket x squared minus 2x minus 3 equals 0. Dividing through by 3 and factorizing, you'll get x minus 3 times x plus 1 equals 0. So therefore x equals 3 or x equals negative 1 is a double root. But it won't be both of them, because if they were both double roots, you'd end up with an x to the power of 4. Okay, and that's not possible. So let's look at p of 3 and just see what we get. And we can also try p of negative 1. So p of 3, actually we're not going to get 0 because we've got this constant c and we don't know what it is. So p of 3 is 3 cubed minus 3 times 3 squared minus 9 times 3 plus c. Now actually we've got cases here. So if x equals 3 is a double root, just squeeze that in. So if x equals 3 is a double root, then p of 3, which is equal to that, will equal 0. In other words, 27 minus 27 minus 27. So 27 minus 27 is 0. And I've got negative 27 plus c is 0, so I'll get c is 27. So if x equals 3, I should probably underline that. So if x equals 3 is a double root, then p of 3 will equal 0. We've just calculated what p of 3 is here, and we would get 0. This means that c would be 27. Now, if x equals 3 is the double root, then we could let the roots be 3, 3, and alpha. Okay? Now we know that the sum of the roots, so sum of roots equals 3 plus alpha, which is minus b on a. So we get 6 plus alpha. Now minus b is negative 3, which is positive 3 on 1. Okay, so we'd get that 6 plus alpha is 3, or we'd get that alpha is negative 3. And so therefore the polynomial in x would be x minus 3 squared times x minus negative 3, which is x minus 3 squared. Sorry, can't see. So if x equals 3 is the double root, then you'd get your other root, your third root would be negative 3. So your polynomial in x would be x minus 3 squared times x minus negative 3, or x minus 3 squared times x plus 3. That's one case. Now, the other case, if x equals negative 1 is the double root. See, we don't know what the double root is because we don't know what c is, okay? So if x equals 1 is the double root, then p of negative 1 would equal 0. Now, p of negative 1 is negative 1 cubed minus 3 times negative 1 squared minus 9 times negative 1 plus c, which is equal to 0. And you would get negative 1 minus 3, which is negative 4, plus 9, which is 5, plus c is 0. So you would get that c is negative 5. So therefore, we would let the roots be negative 1, and beta. Okay? Now, so we know that sum of roots equals minus b on a, which is 3 on 1, which is 3. Okay, and our roots are negative 1 plus negative 1 plus beta, which is 3. So therefore you'd get that beta is 5. And so therefore your polynomial in x is x plus 1 squared, because if x minus 1 is the double root, it's x minus negative 1 squared times x plus 5. Okay? All right. So notice you couldn't do it by inspection. We had to do this substitution in here to get that c is 5. I suppose we could have put c is 5 then and worked it out by inspection. Or you can do it like this, the sum of the roots, and work out what that additional root is, beta. Okay? All right, that's the end of that example. Now for our last example here at the bottom of page 11. Now we've got that if ax cubed plus bx squared plus d equals 0 has a double root, show that 27a squared d plus 4b cubed is 0. So let's just let the roots be alpha, alpha, and beta. So let's look at sum of roots. So sum of roots, obviously we can't really be differentiating this or anything like that, okay? Sum of roots is equal to alpha plus beta, which equals minus b on a. So we've got 2 alpha plus beta. Now, minus b happens to be b, and a happens to be a. So it's minus b on a. I'll call this equation 1. Now let's look at our product of roots. Now this is looking okay because we've got a b and an a. Product of roots would be good because this is the constant term. Notice it must be plus cx, but obviously c is 0. Okay, and d, minus d on a, we'll put a d in here as well. So product of roots looks like it would be okay. Okay, one sec. So product of roots is alpha times beta, and that equals minus d on a. So we've got that alpha squared beta equals minus d on a, and again d is d, so it's minus d on a. So I'll call this equation 2. Now let's just look back at our original equation. We've got that a is a, b is b, c is 0 because there's no x term, and d is d. I'll just put that there, up there, so that we don't lose track of that. Okay, now we still have to try and show that 27a squared d plus 4b cubed is 0. I'm also going to do product of roots 2 at a time because I can't really see what we can do here if we make, say, beta the subject. We're still going to have alphas everywhere. We're not going to be able to eliminate the alphas. So I'm going to do product of roots 2 at a time. So that's an at. Now we know that that is equal to, now if our roots are alpha, alpha, beta, it would be alpha times alpha plus alpha times beta plus alpha times beta. So that would be alpha times alpha, which is alpha squared, plus alpha times beta plus alpha times beta equals c on a. Now this is good because c is equal to 0. So we've got that alpha squared plus 2 alpha beta equals 0 because we know that c is 0, which means that 2 alpha beta is equal to negative alpha squared, and dividing both sides by alpha, we get that 2 beta equals negative alpha. So this is pretty good because we can make a substitution for alpha when we can say here that alpha equals negative 2 beta. So by doing this product of roots 2 at a time, we now can write alpha in terms of beta. Okay, so we don't have two variables there. Okay, so I'll call this equation 3. Now let's start again with equation 1. So equation 1 is 2 alpha plus beta is minus b on a. Let's sub alpha equals negative 2 beta into equation 1. And we get that 2 times negative 2 beta plus beta equals minus b on a. So we've got negative 4 beta plus beta, which is negative 3 beta, is minus b on a. Or we get that 3 beta is minus 3 on a. Or we could say that beta, so I'm just going to come over here. Oh, actually, I'll fit it down here. So beta, 3 beta is b on a, just swapping sides or multiplying both sides by negative 1, or beta is b on 3a. Okay, so beta is b on 3a. Now let's have a look at what we're trying to get. See, we've got a 4b cubed, okay, and this a squared and a d. And over here, we've got that beta equals b on 3a. So we're trying to come up with a b cubed term. So what we're going to do is just cube this. So therefore we could say that beta cubed equals b cubed over cubing. So cubing both sides, we get that beta cubed is b cubed over 27a cubed. Okay, I'm going to call that equation 4. Okay, now let's look at this expression here, and we can do again a substitution for alpha. So let's look at equation 2. Alpha squared beta equals minus d on a. That's equation 2. If we sub alpha equals minus 2 beta into equation 2, we get that minus 2 beta squared times beta equals minus d on a. And that would give 4 beta squared so we get 4, actually beta squared times beta is 4 beta cubed is minus d over a, or beta cubed is minus d over 4a. Okay, now I'm going to call this equation 5. So here we've got two expressions for beta cubed, okay? So it is a bit hard to think to do this one. So if you would have done this one first, substituting into equation 2 and got beta cubed is minus d on 4a, you could have then come back and just substituted what beta is into there, okay? So putting equation, let's sub equation 4 into equation 5. So if you didn't do that, that's okay. I would have just subbed beta into there, and you would have got that b cubed over 27a cubed equals minus d. Sorry, can't see this. Equals minus d over 4a. Now let's just multiply, just cross multiply. So we would get 4ab cubed equals minus 27a cubed d. And if we just divide through by a, we get 4b cubed equals negative 27a squared d. And if we take everything over to the left, we get that 27a squared d plus 4b cubed equals 0. And that's the end of that example. So like I said, this probably would be a bit hard to do. If you do this one first and then just sub your beta into that, you would have come up with this same thing. Okay, that's the end of our roots of multiplicity. And the next video we'll start from page 12, and we'll be on uses of undetermined coefficients. So now you'll be able to finish off exercise 3.2.